Magandang araw po sa lahat. Ako po si Daff, the Data Associate for the project. Sa Lecture 1, naturuan po tayo how to clean the data, how to prepare the data. So, ang next step po nun is to learn how to analyze the data so we can get insights for decision and policy making. Sa lecture na ito, I will introduce to you the basics of quantitative analysis. At the end of this lecture, we hope to provide you with the basic skills in performing quantitative analysis. So first, pag-uusapan natin what quantitative analysis is, what are its benefits, and how essential it is in the decision and policy-making process of an organization. Then, I will be talking about some common tools for conducting quantitative analysis. And lastly, what are the different types of analysis methods and some examples using the tool that perhaps everyone is most familiar with, which is the Microsoft Excel spreadsheet. Okay, so by now, I'm sure lahat po tayo ay aware that national government agencies and local government units have been collecting a huge amount of data from daily business operations and surveys. For example, meron po tayong Community-Based Monitoring System or the CBMS, which includes data on health, nutrition, housing, income, employment, and many others to capture the different aspects of poverty in the community. Meron din po tayong National Household Targeting System for Poverty Reduction or listahanan of the DSWD, which is a database of who and where the country's poor are. We also have the Registry System for Basic Sectors in Agriculture or RSBSA, which contains data on the farmer, farm laborer, and fisher folk. Meron din tayo ng Census of Population and Housing na regularly ginagawa ng PSA. It includes a comprehensive data on the size, composition, and distribution of population in the country, pati na ang existing housing units, migration and fertility data, usual occupation and industry data, and marami pang iba. We also have the Field Health Service Information System ng ating DOH, which is the designated National Health Statistics and contains data on several public health programs, data on notifiable diseases, leading causes of morbidity and mortality, births, immunization, and other health-related data. Kinokolekta po ito per city or municipality. And just recently, dahil po sa COVID-19, meron po tayong COVID-19 Information System ang ating DOH. Daily ang collection ng data nito sa bawat LGU. And from the previous lecture, nakita natin kung ano-anong data ang kinokolekta dito like number of COVID cases per city or municipality, patient's age, health status, date of confinement, date of recovery, and marami pang iba. Pero paano ba ginagamit itong mga nakukolektang data? Unfortunately, from our baseline survey result, sa perspective ng ating partner LGUs, data are collected mostly for reporting and filing purposes only. Therefore, much of the value of data remains untapped. So the next main question now is, how exactly can we make sense of data? How do we get information from data to turn them into insights for policy change? This is where quantitative analysis can help us. QA is a scientific approach to decision or policy making, whereby raw data are processed to produce meaningful information. So QA often gives valuable insights that help ensure decision makers and policy makers come up with actions or solutions that are accurate, timely, and reliable. Take, for example, our COVID-19 experience. Since the start of the pandemic, data are collected daily and then analyzed dahil ito ang basis for the many decisions and actions in response to the health and economic crisis. Through QA, we derived answers to relevant questions like, gaano ba kabilis ang spread ng disease? Anong lockdown measures ba ang dapat i-implement? Ilang days ba dapat ang quarantine period? Anong age group ba ang pwede at hindi pwedeng lumabas? And marami pang iba. So, to give us an idea of how quantitative analysis serves as an integral part of an organization's decision or policy-making process and implementation, we have this diagram by Donald Waters. Suppose there is an identified problem or challenge na gustong ma-address ng ating LGU or organization. Actually, hindi lahat ng problem ay entirely quantitative. And human skills are also important, like intuition, experience, or personal judgment. But a more scientific approach is that LGUs should always consider all available data or start their data collection activities to gather sufficient data. Then conduct quantitative analysis and based on thorough evaluation and assessment of results, make a decision or craft a policy that they can eventually implement. Ang benefit ng quantitative methods, as mentioned earlier, is that it gives valuable insights before reaching a decision. We see here another type of data analysis method called qualitative analysis, which is also vital in the usual approach to decision and policy making. And we will have a separate discussion about it in another lecture. In summary, after a problem is identified, it is best that an LGU or organization conduct both quantitative and qualitative analysis method before making a decision or crafting a policy that they will implement eventually. As an example, let's consider how can LGUs respond to the challenges posed by the COVID crisis. There are many different datasets that the LGUs can consider for analysis, and one could be the COVID-19 Information System data by the DOH. Let's take a look at the dataset from the Lecture 1, which records the COVID cases in the provinces of Albay, Camarines Norte, Camarines Sur, Catanduanes, Masbate, and Sorsogon in Bicol since the start of the pandemic until the end of 2021. As you have seen, this dataset includes different columns or variables like age, sex, provincial residence, city or municipality residence, barangay residence, health status, date of confinement, date of recovery, and then the recovery period. The rows represent the COVID patients or cases or observations, and each value in a given column describes the characteristics of the individual. We have here a total of 52,636 cases. So the next question is, how does QA work? QA make use of statistical techniques in order to present and interpret data. At the simplest, conducting QA provides basic information about the dataset or characteristics of a sample. For example, gusto natin malaman how many children or senior citizens were infected of COVID during the period or ilang persons ba ang nagka-COVID sa bawat city or province in Bicol. Next, it highlights the potential relationships between the variables. For example, nagmamatter ba ang recovery period ng tao from COVID sa kanyang age? Before I discuss the measures, we first need to get ourselves familiar with the various tools for conducting analysis. Fortunately, now there are several softwares developed to perform analytical processes. Some of them are actually free or downloadable online. Perhaps all of us are familiar with Excel spreadsheet. It is commonly used to compute basic statistics and for immediate processing or cleaning of data, just like what was illustrated in Lecture 1. There are also some widely used statistical analysis tools such as SPSS or the Statistical Package for Social Sciences, and SAS or the Statistical Analysis System, and Stata. These programs provide basic to advanced statistical functions. Of these three, Stata is considered the most user-friendly data analysis software. It can perform many statistical tasks, including visualization. But a major disadvantage of these tools ay hindi sila for free. Then we have R and RStudio. R is popular software for analysis dahil una, we can download it online for free. Pangalawa, it has a community of users who share their work online, so maraming resources for learning the tool. And then third, it gives nice tables, charts, and plots and other visualization outputs. There is also Python. Just like R, Python is an open source software and has a large community of users online, and it can be used for many advanced analysis processes. Unfortunately, ang disadvantage naman nila ay it would really take time to learn the programming languages they operate on. Basta po, ang mahalaga that we have to bear in mind is that for effective quantitative analysis, we need to be familiar with the appropriate software. So I hope all of us can learn how to use any of these tools in the future. In the meantime, since most of us are familiar with the Excel, we will use this tool in the examples we have in the next slides. Now, how do we get the basic information about the dataset or characteristics of a sample? There are three common measures. First, we get the frequency and percentage distribution, then the measures of central tendency, and then measures of dispersion. These measures allow us to see the big picture and the finer details of the sample. Frequency distribution includes a list of all response categories and the number of observations for each category. For example, how many COVID cases are aged 60 and above or 20 and below? While percentage distribution displays the category size relative to the size of the sample. So like how much of the total COVID cases are senior citizens?
Okay, let's try to derive the frequency and percentage distribution using the dataset that we have. Suppose we want to see how COVID-19 affected the different age groups in Bicol region. The first step is to create a pivot table. So click on any cell within the table. And then click Insert, then choose Pivot Table, then choose From Table or Range option. A dialog box will open which will let you choose where you want the pivot table to be placed. If you want it in the existing worksheet, choose that option and then click on the cell where you want it to appear and then click OK. This opens to the pivot table fields which displays all the columns or variables in the table. Since we want to check the frequency distribution of the age variable, drag age to the rows area and again drag it to the values area so we can see the count of COVID patients per age. The table will appear showing the age in one column and the count of COVID cases per age in another. Then since we are more interested to the age group, right-click on any cell in the age column and click the group option and then choose the interval, say for example 10, or that is to say we want to group age by 10 years. We can also change the column labels to age group and frequency. So now we have the frequency distribution of the variable age, and again we have 52,636 total individuals in this dataset. A total of 36,419 were 20 to 59 years old, while 9,396 of them are aged 60 and above or senior citizens. So next question is, how many percent of the total number are the working age group and the senior citizens? We add another column to solve for the percentages. First, open the field list again and following the previous step, drag the age variable to the values column. Then, when the table appears, right-click any value on that column to change it to percentage. click Show Value As and click Percentage of Column Total. And so we will have this table as the final output. Around 70% of the COVID cases are working age group, while 18% are age 60 and above. We can also check how many COVID cases were recorded per province or city or municipality, and particularly how many died and recovered. Again, we create a pivot table just like what we did in the previous slide. Then drag provincial residents and city or municipality residents variables into the rows area, and then drag the health status variable to the columns area. And then drag again the health status variable on the values area to see the count of COVID cases per province or city or municipality per health status category. So we have the table here. Again, we can change the labels of both rows and columns. Based on this data, Albay recorded 11,165 cases. For Legazpi City alone, they have 3,518 cases, where 3,336 recovered, and sadly, 66 died. We can also compare the cases on a provincial level. You can see here Camarines Sur recorded the highest number of cases at 22,156. 20,960 recovered and 480 died from COVID-19.
Another way of describing the sample is using the measures of central tendency. It is the statistical measure that identifies a single value as representative of an entire distribution. The single value that is most typical or representative of the sample. There are three common measures of central tendency: the mean, median, and mode. The mean is the simple arithmetic average of a set of values. To get this, we sum all the values and divide it by the total number of values. The median is the midpoint in a range of numbers when all of them are orderly arranged. It is also called the 50th percentile, meaning 50% of the values in that distribution fall above that value and 50% fall below that value. Then the mode, or the frequently occurring number in the data. The Excel formula for these are shown in this table. For the mean, we use the average function and set the range for which you want the mean or average. Similarly, for median, we use the median function. And for mode, we use the mode.mult function, which will return the most repetitive values, not just the single value, in an array or range of numbers. Another way of describing the data or the sample is by measure of dispersion, and the most common is the standard deviation, which is a measure of how far each data value deviates or is different from the mean, or how much the data scatter around the mean. A standard deviation equal to 0 means that all the data values are equal. A large standard deviation means that the data spreads out. And a low standard deviation means that the values are close to the mean or average.
Let's consider again the data set we have. Notice that case 1 took 33 days to recover. Case 2, 25 days. Case 3, 30 days, and so on. Suppose we want to know first the average recovery period of COVID patients after confinement. So using the dataset, we consider only all recovered patients and check the measures of central tendency, the mean, median, and mode of the variable recovery period. First, we derive the values individually. Let's check first how many observations we have, or the total number of values using the count function. We see that there are 6,618 recovered patients in this dataset. The minimum recovery period is 5 days and the maximum 40 days. Now we get the mean or the average recovery period using the average function. The mean is 15.29, or the average recovery period of the patients is about 15 days. The median is also 15 days, but the mode is equivalent to 10 days, which suggests that most patients recover in 10 days after confinement. There is another way to get these values using the data analysis add-in in Excel. Click Data, then Data Analysis, and then choose Descriptive Statistics from the dialog box, and then click OK. Then choose the input range, which is the range of values you want to check the mean, median, and mode. Then choose the output range, or the cell where you want the output to appear. And then click OK. This gives us the summary statistics of the variable where we see the mean, median, and mode. So now, let's check the histogram or the distribution by recovery period in the next slide. Now we see the graphical representation of the distribution by recovery period generated from Excel. Here we see that the data is somehow symmetrical, so the mean and the median do not really vary. Take note that when the distribution is skewed, the median and the mean may differ. The more skewed the distribution, the larger the difference between the two. The question then is, when should I refer to the mean or the median as the single value that is most representative of the sample? Well, the mean is sensitive to extreme values or outliers, especially when the sample size is small. So when there are values that are exceptionally high or low, which skew the average value or the mean, then we can cite the median, which is more representative. Here we also see that the mode is at 10 days, meaning it usually takes 10 days for people to recover from COVID. The mode is the measure that is least used of all the measures of central tendency, but is especially useful for certain variables.
So how about standard deviation? Going back to our data, we can see here case 1's recovery period is 33 days or 18 days longer than the mean value of 15 days. Case 5 recovers in exactly 15 days, and case 7 recovers 2 days shorter than the mean value. So we can see that the people's recovery period has some deviation from the mean. So how much does it deviate from the mean value on average? This is what standard deviation tells us. In our example, the standard deviation or the average deviation from the mean is 5.86 or around 6 days. Another use or benefit of quantitative analysis is it highlights the potential relationship between the variables. One of the measures is correlation. Correlation is particularly helpful if you want to know how a variable moves when one changes. Will a variable B go up, down, or stay the same if variable A goes up? Say for example, gusto natin malaman kung ang age ba ay positively correlated to recovery period. Meaning, the higher the age or the older the person ba, the longer the recovery period. Let's see this in this last example.
So we have here only two variables, age and recovery period. First, we check the correlation matrix or the table that shows the relationship of these two variables. Again, this is possible using the data analysis add-in in Excel. Click Data, then Data Analysis, and then choose Correlation, and then click OK. Choose the input range, and since I included the labels in the first row, check the corresponding box, and then choose the output range, and then click OK. The correlation matrix shows after, and here we can see that the coefficient between The correlation coefficient between age and recovery period is 0.055. Although it is positive, the coefficient is small, which suggests that the variables have weak relationship. We can also check the relationship by creating a scatter plot.
Okay, we have here the scatter plot generated from Excel, which shows the correlation between age and recovery period. By the way, we will be introduced to more data visualization techniques in the next lecture. Okay, so here we see that the trend line is sloping upward very slightly, which supports the result from the previous slide that although age and recovery period are positively correlated, their relationship is weak, which means that older people do not necessarily spend longer time to recover. So, if it's not age na nagmamatter why people spend longer time to recover from COVID-19, this suggests that there are other factors that affect the duration. So, perhaps exploring more advanced analysis techniques or methods can help uncover these factors. In summary, in this lecture, we discussed how quantitative analysis is an integral part of the decision and policymaking process of an organization. We also talked about the common tools for conducting analysis, and the important is to start from the basic and learn the basic functions for describing the data or the potential relationship between the variables. We also talked about the different types of quantitative analysis methods, and we derived the frequency and percentage distribution, the measures of central tendency, measures of dispersion, and correlation. These measures provide a macro view and the finer details of the data that could provide useful insights for decision and policy making. So I hope that you learned in this lecture and it made you more interested to make your LGU follow the usual process for decision and policy making, which includes quantitative analysis. Maraming salamat po at magandang araw po sa ating lahat.